So I'm here for the late night talk. So I'm going to do some storytelling. So imagine a cross-functional team of specialists. They are entering a room, or as it's these days, probably they're entering a virtual room, so a video conference. So say two iOS developers, two Android developers, two backend developers, a designer, and a product owner are entering a room. They're a Scrum team, so they have many meetings. So there they are, talking to each other. What happens next? We're 30 minutes into the meeting, and now what was that? Apparently, you see the iOS developers and the designer are thinking along. The product owner has a question. They're heavily involved in a discussion. Yet somehow we lost 4 people here. They turned off their video. So in a real meeting, maybe it would have looked a little bit like that. Apparently, our Android and backend developers have dozed off. How could this happen? What was going on? So, well, maybe they have a sprint backlog that looks like we have a story for iOS, we have a story for Android, and a story for backend, which are not necessarily related because backend needs to come first, Android needs to catch up. And so the iOS developers are talking, the other people dozed off because they cannot or they are not collaborating actively. You already got an introduction about me. I've been working at an agency, Karlmax Berlin, for 5 years, and I've just joined a new team at SoundCloud as engineering manager. So I've seen many teams and many projects in the past, and currently I'm onboarding and meeting my new team. So I was thinking, what could I talk about here? So I'm telling you stories about what I've seen, people collaborating, or not so much sometimes. But I think we are going to come to the more happy stories next. So what I'm going to cover is first, how did we get here? How did we get to this team with the dozing Android developers? Collaboration, how could we do better? What are patterns I've seen among developers, both in planning and in coding? And how could we share artifacts? How did we get here? Sometimes we've seen teams playing the catch-up game. So earlier, in the early days of iOS and Android, we did not have cross-functional teams. We typically started off with platform teams, and typically we started with one platform because development is expensive and nobody knew whether this was going to be interesting at all. So often companies started with an iOS team. At some point, they realized they also want to do Android. And from there on, you had the catch-up game, and constantly one platform was ahead of time. So this is actually not so good, because in the end, when you have users, you want to serve all of your users the same features. Especially if your company has some visibility, then people will start talking about your app with their friends, and their friends are on Android, and now they're missing these features. So there's the holy grail of feature parity. Some people are arguing that actually feature parity is overrated because from a user's perspective, fair enough, there's few people like me who have several phones in their pockets. Most of them have one platform. But again, people have friends, you have visibility, so people will talk. But I think the most important point for feature parity is actually your team yourself, your company, because you constantly keep thinking about everything you're building. You keep thinking about one product. And if you don't have feature parity, you are constantly balancing things. You're playing the catch-up game. And one other thing is happening if you don't consider everything at once. And that is you are building up independent piles of tech debt. So you see in my little drawing there, the iOS developer actually has it simple to just place the new triangle somewhere in the code, whereas for the Android developer, it is hard to find the spot where this can go. And if you're playing the catch-up game, if you don't develop along with each other, this may happen. So let's look at some other approaches I've seen in the past. Let's start with what people are doing during planning and design when they're not dozing off, but actually collaborating. What is one of the hardest things in computer science? Naming. Naming is one of the hardest things. Yet it is super important. It is super valuable if you have a consistent language among everybody in the team. So not only Android developers, iOS developers, backend developers, but also product people, designers, if you have it in your code as well as in all your other docs. I mean, maybe even business could talk the same language, but that's maybe asking too much. But at least among all those other people, it would be super valuable if you had a shared language, because then also you can just search for a term and you will find where else it pops up. So for example, I mean, let's think about an app that allows you to do a walking tour around a city. So you are looking at sites, or is it points of interests? Or also we like short terms, so it could be POIs. Yeah, and if you don't talk about terms, one team is using the one term and the other is doing the other, so it's just harder to move around when you're looking at the other code. And when it comes to abstract concepts, it's even more important because it's even less obvious what we're talking about. I was recently told about an Android team that when it comes to analytics, the Android team is talking about tracking and the iOS developers are talking about tagging. And sometimes they don't know what they're talking about while they're actually doing the same thing. What I've seen, what helped is actually simple. I mean, it's creating a glossary in a wiki. So just during planning, you keep building your glossary, you keep adding new terms, and you actually take the time to decide what is the term that we're going to use consistently over the teams. And even on a pull request level, this might be a reason to say, hey, sorry, we decided we call this a point of interest. Please rename. Other teams are aiming for unified user flow. And this is not the same as the same UI, because as native developers, we are aiming for bringing the best native experience, so the most native and most shiny thing on our platform to our users. So of course, we don't want to have the same UI on Android and on iOS. Yet, some projects and teams have set up the rule that still you want to have a unified flow. So unless there is a reason to treat something differently, you actually want the user to go through the same steps. So for example, you have an onboarding tour and there's a login button or sign up button because it's an onboarding tour, you're new, you want to sign up. Where does this button lead you to? This should be the same for both apps. Again, not so much for the users, but for the teams building them. A separate topic that is related is how do teams actually collaborate with their designers among multiple platforms? And it feels to me there's no established best practice here. Some teams have designers who deliver high-resolution designs for both platforms. The traditional approach in the catch-up scenario is they deliver only one platform and the other platform feels not very well supported. On the other side, they have a bit of freedom to catch up, but typically they are complaining. It used to be the Android developers crying. I've heard these days it's also sometimes the iOS developers crying that Android was first. So better patterns, what I've seen, so some designers rotate. So sometimes they just switch. They do some screens for Android, some for iOS, and expect the developers to do canonical adjustments for the other ones. If your team has adopted a design system, it will also be simple for you to come along. Other developers wish they don't get high fidelity designs, but they just get wireframes because actually they know how to do the canonical thing for their platform. If you have unified user flow, what comes next is the unified handling of corner cases and thresholds. something that also may lead you into trouble if just everybody defines their own constants. So I don't know, my favorite thing that I have not figured out yet is why does Twitter on Android only shows 1/3 of the tweets compared to iOS if you scroll to the end, if you ever have too much time. Something that helps you to not have this independent piles of tech debt is actually talking about design, this time on a code design level, and data flow. So you don't want to have the same architecture because this would be probably too much, because also you want your code to be in line with best practices on the operating system. And it's not, you don't do the same things typically, but on a data flow level, you probably want to do the same things. Like, what data do we prefetch? What do we cache? What is persisted? What is the single source of truth? I've been at an Android team that was working together, but not as closely together with an iOS team. And we've had this problem. So somehow we lost the moment in time when the iOS team had decided to actually drop the core data database. So they ended up having a very lightweight app that just cached requests. Whereas on Android, we had this massive, complicated construct of MySQL, and not MySQL, of course, SQLite inside of it. Actually, it was a lot of handwritten codes because it was in the old days when we had no room on Android. So we had difficult conversations from there on because we kept hearing, why are the Android developers so much slower? Turned out, we did not do enough whiteboarding together. We have not talked enough about what we are actually doing. So we were sitting on a very different pile of tech debt here. I've also seen teams overdoing this. If you go too much to the direction of unified architecture, also you're losing some things. But again, on a high level, it helps if you know where your data is going and where it's coming from and what you're persisting. Next up, I want to talk about code. And here comes my one piece of quantitative study. I did a Twitter poll. So I asked, can you actually, as a mobile developer, can you actually build for the other platform? Turned out, roughly 60% of the people can do it and do it seldom or sometimes, or maybe even tiny number of people do it frequently, whereas 40% either don't care or cannot build for the other platform. So I think the biggest hurdle here is Android people who are not on macOS, so they really cannot build for the other platform. Yet I've seen in teams it's not the only reason. I've seen people who just don't get access to the source code for whatever reason. Some tools are missing, or also not so seldom, they just tried it once and it did not work out of the box and it wasn't simple, so we did not follow up. Well, of course, I mean, just building for the other platform is not important because we have CI for that. But typically, you might want to start reading the other code, and it's just not fun if you open it up in the IDE and everything is red and you cannot press the build button if you actually want to try it around. So the question is, if you want to get started also looking at this other code, that's actually hard, right? Because that's a completely different thing. Yet, I think reading and writing code, also when we're speaking about code literacy here, let's split it into reading and writing, because it is two different things. And also reading, like when a kid is learning to read, it's not boom, now I can read. It's starting with letters, then there's words, and maybe a year later, it's stories and books. And similar, I think there are several levels of code reading literacy. So you start with a code snippet. I'm doing this fetch thing and I need to do a filter in order to only find those songs that are new but not too new and are these genre, blah, blah, blah. How did you do it on the other platform? Somebody sends you over a snippet. Can you read that? These days, Kotlin and Swift are getting closer together. I mean, not necessarily you can read it because we come to that later, but still, you start reading the other platform's code on a code snippet level. At some point, maybe you only need the pointer to a file. And when you're really reading proficient, you will find your way around the code base. People don't need to give you the pointer. You know how to find things. What may help here? I've seen that coding guidelines do help. Different people, I mean, it always depends on the level of experience that people are having. Sometimes the most idiomatic way is not necessarily the most newcomer-friendly way. I don't give any rules here. Also, you know, from my intro, I'm a manager and not a developer. But what I can say as a manager, that it is worth talking about that. And if questions keep coming up, you could also think about maybe there is an easier way to do this. For example, with Kotlin, there's inferred types, yet it's just easier to read something at the first time if you actually put the type there, and it does not cost you so much. Just an example. Next, of course, writing code. And the interesting thing here is you start thinking, who am I? What's my level on this other platform? Because I'm used to being a senior developer, and now I'm here and I'm all new. I'm a noob, or I'm a hobbyist, or am I a junior or a mid-level developer, or am I senior? You will probably not be the same level as before, but also you're not losing everything. Because, I mean, yeah, you are not the senior who should make all the decisions by themselves, because actually you don't know all these bits of this as a platform. On the other side, if you're a senior, hopefully you know what you don't know, and you know how to ask questions, and you will not lose that. When people can now read and write the other platform's code, the ideal would be the ideal. Is it the ideal maybe that they're the mobile developer? So the person who can just do it all? I'd say, I mean, there are people who are generalists. There are people who are very experienced on both platforms. Yet most people have a main platform and a side platform. Or if you really do both of them, don't expect to be the dual specialist, because it's likely that you will be frustrated if this is what you're expecting from yourself. Because typically if you go broader, you go less deep. I mean, unless you consider yourself a 10 times developer, then you might think, well, I do 5 times on one platform and 5 on the other. Yet chances are you are only human. And so if you think this is going to happen, then you might be frustrated in the end. So now how do we get there? How do we make any progress, or how can we get started? So one thing that is especially valid in small teams is to think about cross-platform code review. So imagine your other iOS developer on your team is on vacation. What do? Who is going to review your code? In many teams, it's common practice that you reach out to someone completely at somewhere else, so the red shirt Apple developer here, who does not know so much what you're actually working on, but they know iOS. Whereas actually next to you is this Android developer who knows your business logic, but is not so familiar with iOS. And I would say it depends. I mean, also it is not necessarily the same person who should do the review of all of your pull requests, because it depends on what you want from the pull request review. If you feel someone should look at the architecture, then probably it should be the other platform developer. Yet, to be honest, talking about architecture on a pull request level is also not ideal, because it's actually too late to change everything. So also, but there is a lot of value if your peer from the same team reviews your code, because you are creating alignment, whether you are actually doing the same thing, and this developer knows your business logic. So also, I think it is always worth to actually question the practices that you're having in a team. So why do we actually do code review? What do we want out of it? But also, I must tell you, as a manager, I know it is not that easy, because a typical thing managers are doing to stay a bit up to date with what people are doing is code review. even when they've stopped coding. And with the changes going on after a couple of years, it's not getting easier to actually be proficient enough to tell people. But again, we are senior enough to know what we don't know. So of course, I'm still more familiar with Java because that's what I actually did as a developer, and not so much with Kotlin. Next up, cross-platform pairing. One way to get up to speed or to compare is to actually sit together in front of one machine. Many teams are actually not pairing on a regular basis, but rather when they have something to debug, so when stuff gets really complicated. So this is also a real use case and something I'm seeing, that in this case, you start sitting together and comparing what your apps are actually doing. It also helps because you don't know the tooling, but you will have your peer next to you who actually walks you through the code base. I've been to a talk where people had been taking this completely to the next level. And bear with me, I'm sharing my own sketchnote here. So also a shoot out for sketchnoting, because actually this talk was never published. So let me rephrase it very shortly. A team at Novoda, another Berlin company, did one greenfield project, a project from scratch, that they completely done with cross-platform pairing. So they always had two people sitting together, iOS developer, Android developer. They always started with one platform, carefully taking care that really the business logic is separated. And once they were finished with a feature, they immediately switched to the other platform and ported the code. Basically kept the business logic and rewritten their UI. And also they made some upfront decisions about using similar architecture, similar tools. And for example, they decided to let go of Xcode and rather use AppCode so that they have a more similar environment. Something else, how we could take collaboration to the next level, or how we make it actually mandatory to collaborate, is if we're actually sharing something. So let's look at shared frameworks. So when you're integrating a third-party solution for something, a common thing is that you typically want to pick the same thing from the same vendor for multiple platforms. So for example, you might choose Firebase for event tracking and push notifications. The benefits are obvious because you have one console. So there's even a shared thing for your product people and all the other stakeholders to work with. Yet, especially when it comes to smaller vendors, or well, actually it could happen everywhere, just because two SDKs are from the same vendor does not necessarily mean that they have the expected level of similarity. It could also be that this third-party company has developers that are not actually collaborating, so you may end up with two very different SDKs. So when picking an SDK, I would recommend do not only pick that it is reasonably, that it looks reasonably nice on your platform and idiomatic. Also check that it has a reasonable level of similarity between the two platforms. And yeah, you notice I keep talking about two platforms. We do have backend developers and maybe web developers too, yet in my personal history, it's been mainly only two of them. Another thing you might want to share is artifacts that are often changed, because you don't want to have them in both platforms individually. You want to have a single source of truth. One example is translations. So providers like PhraseApp.com are offering a solution where you're translating everything in one place, yet still you need to be conscious about a couple of things. You need to have a consistent naming scheme that actually works for both platforms, Android and iOS, because for Android there need to be valid Java identifiers. Yeah, and there might be other similar things. So, for example, test data or internal configuration files might be something that you want to source from, get from a central point and include in both of your builds. One thing that is often shared is the API. That is like a classical thing. You are sitting with your team in a planning session and you are defining the API. When you do that, what you're actually doing is like a bit of a waterfall-y approach, because you sit there and you define the interfaces, and afterwards, this is what you're going to share. There's another moment in the development where it actually makes sense sometimes to look at this API and compare, and that is when you have maybe these independently developed apps. It is also sometimes very helpful and insightful if you actually check a trace of your requests that both apps are doing, to also see how much you diverged and what you do differently. Some other patterns, now I'm going a bit quicker, some other patterns that I've seen among the industry, one thing is a server-driven UI. So because you don't want to implement this complex business logic twice, you are rather doing more on the backend. And for server-driven UI, you are sending JSON files that are actually only rendered then by the platforms. So the first one I heard a talk about this was Airbnb. For registering their new apartments, this was something that was just changing very often, all the questions that you need to answer in order to register a new apartment. Yet there's also other companies doing. There had been talks from SoundCloud, Zalando, Spotify, and others. Links are at the end of my slides. Also, one step further maybe, also you want to have the backend as a single source of truth. One thing I've heard in a talk from Nicola Corti from Yelp was code generation. So actually you are, with your backend, you are also generating packages for the model classes. So this time your developers are getting a runtime error instead of, excuse me, of course they don't get a runtime error, they want to prevent the runtime error, but now they get a compile error in case we made something mandatory that was optional before. Something that I've also seen is actual code sharing. So now actually people are working on the same code base. Could be C++ libs, it could be Kotlin native, it could be Flutter, it could be React native, at least partially. So now in this shiny picture, you have a developer, you no more have a platform developer. Yet I've driven the adoption of Flutter for small apps in the past. There are technical hurdles, there are complicated things, yet when we only look at it from the collaboration perspective, it has been a big win for this team. And it was really as good or even better than we expected, because the developers really were focusing on features. There were platform specifics, but they were like the exception instead of the default. So team and collaboration wise, this was a big win. Yet you see in my picture, I have the small platform developers in the background. When you do cross-platform development tools, when you're using them, you want to have the experts available. So why do we actually want to collaborate? I didn't want to start with this because all the answers are kind of cheesy, but I mean, yeah, pick for yourself. You might want to leverage knowledge. You want to create alignment along your team. You want to create better products together. You might have small teams, and also just helping each other is like a core human behavior. And also it's a core agile value. Someone on your team is blocked. You want to help this person. Yes, you can and you should. Developers like learning new things. Talk with your team and think what is your answer. But I mean, at very least, you don't want to fall asleep during this planning meeting. I think this is the least you probably want to do. So thank you for your attention. And here are some more links. And I will publish the slides later today.